we were in the last lecture we took this question to design a circular column for a load of 2000 kilonewtons. Now here you will be providing the helical reinforcement of 10 mm in dia, and you have to design this column for M30 grade of concrete and Fe500 steel. What's also given here is that the column is under actual eccentric, sorry, actual concentric loading. So, and the column, as what we saw, it's a 3.5 meter in length. We assume 300 mm. So, any one of you who redesigned this for 500 mm? 82, Ayman?
Yes, sir.
Did you redesign it for 500 mm?
Yes, sir.
So, so explain to me when you redesigned it for 500 mm. In step number 1, D is then 500. It's not 300 now anymore.
Yes, sir.
So this is 500. What was the slenderness ratio that you got?
36.67. So no, 4.55.
4.55. Has anyone else also done it?
Yes, sir.
Uh, is it right? Cylinder
Yes, sir.
4.55.
Yes, sir.
Then step number 3, what was the minimum eccentricity that you got? Oh, this is 500 here. Yes, Ayman.
36.67.
36.67. So it will be the maximum of these two, that will be 36.67. And your 0.05 of 500 comes out to be how much?
25.
20. Which less than the maximum of the two, that is 36.67. So it's okay. We can consider it as a concentric loading still. Then the longitudinal reinforcement. This is 2000 into 1.5. Now what will change here is FCK. Yes, this will change. What is AG now? 500 cross 500. E minimum is 23.36.
Yes, sir.
Yes,
It is
sir.
23.66.
This is 23.36. Then this is slightly higher. Is this 0.05 of what's that value coming out to be? It's coming out to be slightly higher than 23.36 then. So you could take it into the eccentric loading then. But for simplicity, because the difference is quite less, we'll take it as concentric. We'll assume here it's concentric here. It's an assumption here. तो ये कितना आ रहा है? What's the value of ASC that you got ultimately?
One 628.47.
Just a minute. One six 28.
Sir, is it 252540 or it is pi d square by 4? Sir, area निकालना है ना सर, it is circular cross section.
Okay,
तो
okay.
उसका
Right.
स्क्वायर आएगा कि pi d square
Ah,
में?
it's 3.14 by 4 into
Sir,
5.
it's 19349.
It's 196250. So your area of steel is coming out to be 19. कितना आ रहा है?
So 1628.47.
0.47.
Yes sir, sir जो ये ना ग्रॉस एरिया वो आ रहा है 196349.50.
Just a minute. 3.14 divided by 4 into 500 cross 500. So it's coming out to be 196250. 500 पे कर रहे हो ना आप?
Yes
सर
sir.
ए फिर आएगा 1604.29
16
04.29
1604.29. किसी और ने किया है? सेम आ रहा है?
सर मैंने किया था बट मुझे कम आ रहा है इससे।
Let me check again.
सर अगर हम डायरेक्ट पाई वैल्यू देते हैं ना कैलकुलेटर में तो हमें यही वैल्यू आता है 1963. अगर 3.14 देंगे तो 196 आएगा.
3.14 तो
25.
है पाई का वैल्यू.
हाँ
3.14 ही तो है पाई का वैल्यू.
सर डायरेक्ट पाई भी दे सकते हैं ना वैल्यू, उससे
वो
नहीं
तो
कर
वही
रहा
है.
हूँ फिर.
वो तो डायरेक्ट पाई तो वही है. कुछ और होगा नहीं ना. 2355000. Let me check the answer. 0.4 into 30 into 19650 1.05. This is 24272750 and that is 0.67 into 500 335 into 1.05 351.75 minus 0.4 into 30 into 1.05 that's 12.6 minus 1.5 is 339.15 ASC and this value is 2000 272 that's 127 1554. What were you getting it?
यस
It's get
यस
coming
सर.
1554.
हम्म.
Point something. So let's take it 1.1554. So A maximum is 2826 when this was the case. Now it will increase further because now your area of cross section is 196250. So this then becomes this is 0.4 78500 78500 mm square is the value of A max that you're getting, and A minimum is 0.8% of the same 196250. That comes out to be 0.86250. That's 1570 square. So your minimum is 1570 and your maximum is 78500. So your value of ASC is slightly lesser. What you require is lesser than the minimum. Let me check it again. 0.8. This is coming out to be 7850, not 78500. This is 7880 इसमें कम है, and this is right, 1570, and you require 1554, but you need to then provide 1570. So we'll be providing 1570, which is the minimum required. Thereby, what do we have to do while providing the longitudinal reinforcement in columns? If you go to the IS code, there you will come to know. Just we have already discussed this, that you need to provide at least 6 number of longitudinal bars in a circular column, and also the spacing between the bar should be at least 300 mm. So that's the condition of the providing the longitudinal bars. So we have to provide at least 6 bars. Now if we provide of 20 mm, that would mean तो एक बार उसमें 314. So below 20 you only have available 16 mm. Then you need to at least provide 8 number of 16 mm bars. So we will be providing 6 number 20 mm dia bars here. This is what we will be providing. So how do you provide that? You provide them equidistant. Do you know what you could also do here when you got the area of steel required less than the minimum area of steel? You could decrease the size of the cross section. But for that's when you want to achieve an economical design. You do not want any wastage of material. Then you could decrease the cross section somewhere between 300 and 500 mm that we tried. So now here you have 600, six number of bars along the circumference of this. The circumference of this would be, the perimeter of this would be 2 pi r, but the inner one would be this inner one. Between this point and this point, you first have the cover, which is 40 mm. Then this tie given is to be 10 mm in dia. The tie red one is 10 mm in dia, which is the helical reinforcement here. So that adds up to 50. Then you actually calculate the distance between the bars along the center of each bar, that is about this point. Along the center, running the center line running. This is a line, the center line that's running through the bars. You are actually calculating the distance between the bars along this line. So that would add up to 40 plus 10. 10 is the tie up, or the tie. Then half of the bar is 10 again. So that is 60 mm is subtracted from the diameter. So your diameter now becomes 500 minus 60 minus 60. So the core dia, this one, up till this point, this dia is 500 minus 60 minus 60. That's around 380 mm. This is 380 mm. Thereby, the circumference or the perimeter would be now how much? That would be pi d. The core dia DC is the circumference, that would be 3.14 into d, that's 380. It's 1193.2 mm. This is the perimeter of core. So because you require 300 mm distance, minimum distance between the longitudinal bars, but what you are getting here is a distance of just 198, if not 198, sorry, 6. You are getting a distance of 238.64. How? This is 1193.2 divided by how many spacings are there between 6 bars? 5. So that's 238.64 mm is spacing. But as per code, you have to ensure that the bars shall not exceed, sorry, this is shall not exceed 300 mm. So you can provide it within the perimeter is 2 pi r. Someone is asking 2 pi r. This is 2 pi r is pi d. So here you can limit it within 300.
190/6 आएगा ना,
हाँ,
divided by 6.
6 नहीं 5 आएगा. 1 2 3 6. Just a minute. 1 2 3 4 5 6. Yes, 1 2 3 4 5 6. Yes, यहाँ पर 6 आएगा. You have to check the number of spaces in between. What happens in rectangular or other column in this beam, वहां पर आपको एंड के 2 होते हैं, उनके बीच में एक ही स्पेस आती है. यहाँ क्योंकि ये सर्कल है, सो यू हैव 6 स्पेसेस इन बिटवीन, राइट. सो इट्स 190 198. This is 198. .8687. So this has to be within 300. The spacing has to be within 300. So this is okay. Now you need to go for step number 4, which is providing transverse reinforcement. Now, how do you provide transverse reinforcement? Now this is a helical reinforcement that you have to provide. What is given in the code is number 1, in helical reinforcement shall be a regular formation with the turns of the helix. We have already studied this. At the end should be 1.5 extra turn of the spiral bar. And next, where there is an increased load on the column on the strength is allowed, the pitch of the helical turn shall not be more than 75 mm, not more than this. So this is the pitch requirement, and the diameter is the same. Here the diameter is already given to you in this question. This is what is stated in the code. Now what we'll do is we will first of all calculate the volumetric ratio of the column. Why do we need to calculate the volumetric ratio of the column? Because again, it's given in the code. Compression members with helical reinforcement, the ratio of the volume of the helical reinforcement to the volume of the core shall not be less than 0.36 of this Ag by Ac minus 1 into FCK. This is page number 71 of the code. So where now this is the ratio of the volume of the helical reinforcement to the volume of the core. Now how do we calculate that? The volumetric ratio is the ratio of volume of helical reinforcement to volume of core of column. This is a ratio between these. Ratio of the volume of helical reinforcement to volume of core of column. Now you have a helical reinforcement, for example, like this. Now this is located within the column. It's twisting and turning. Yeah. Now for a distance from where it starts up till where one turn ends, एक turn जहां पर खत्म हो रहा है, it's like this actually, going like this. So it's winding through. Now where the turn starts and then it goes back to its original position, it's actually turning throughout the column here, and it's going back to its original position. Now you need to first calculate the volume within one pitch length. How would you do that? You know the diameter of this, it's given to you. The helical bar is 8 mm, sorry, 10 mm. So area, volume would be area of this into the length of this